So friends, let us discuss about prism formula. You know, prism, it is an wedge-shaped material bounded by two refracting surfaces and a base. The refracting surface is the surface through which refraction takes place. If refraction takes place through these two surfaces, these are the refracting surfaces and this is the base. If refraction takes place through these two surfaces, so these are the refracting surfaces and this will be the base. Okay. Now which is the refracting angle or angle of the prism? The angle between the refracting surfaces is called the angle of the prism. If refraction takes place through this and this surface, this will be the angle of the prism. If refraction takes place through this and this, then this will be the angle of the prism. Okay. Now let us derive prism formula. Okay. So students, see here. Suppose this is the section of a prism A, B, C. A ray of light EF is a monochromatic light incident on the surface AB. Let us draw a normal to the surface. N1 is the normal. Then this ray refracted through this prism along FG. Let us draw another normal here to the second surface. The normal is N2. Now you see this FG ray here suffers refraction and emerges away from the prism along GH. Clear? Now you see this is the angle of incidence I1 and this is the angle of refraction R1 for the face AB. Similarly for the face SC, this is the angle of incidence and take as R2 and this is the angle of refraction and take as I2 suppose. Clear? Now in the absence of the prism, this ray EF, in the absence of the prism, the ray EF can move straight without any deviation. Suppose no prism is there initially, then this ray can move straight like this. And GH is the emerging ray. Why are emerging? Due to the presence of prism. If no prism is there, then it can move straight. But due to the presence of the prism, this ray can move along this direction. That means this angle is the angle of deviation D, and this point I will take as K. This is point O. Here angle of deviation is D, which you have to find out. Now see here, what is the value of angle of deviation? You consider the triangle KFG. In this triangle, D is the exterior angle. The exterior angle is equal to this angle plus this angle. Sum of the two exterior angles, these two angles. D is equal to KFG angle plus KGF angle. So angle of deviation D is equal to KFG angle plus KGF angle. But this small angle is equal to total minus R1. This total is equal to I1. So I1 minus R1. Similarly, this angle is equal to this total minus R2 means I2 minus R2. Okay. So this we can write I1 minus R1 plus I2 minus R2. Or this is equal to I1 plus I2 minus R1 plus R2. Equation 1. Clear? Now consider the triangle FGO. R1 plus R2 plus angle O is equal to 180 degree. So in triangle FGO, R1 plus R2 plus O angle is equal to 180 degree. Again you see AFOG, it is a quadrilateral. In this quadrilateral, this angle is 90, this angle is 90 because N1 and N2 are two normals. So these two angles 90 90 180. So remaining A plus O is equal to 180. Okay. So in quadrilateral AFOG, angle A plus angle O is equal to 180 degree. Compare those two equations. What you are getting? Your right side is equal means left side must be equal. That means R1 plus R2 plus angle O is equal to angle A plus angle O. This implies R1 plus R2 must be equal to angle A. Equation 2. Now put the value of equation 2 in equation 1. Here R1 plus R2 is there. When you put this value as A, so deviation becomes I1 plus I2 minus angle A. Equation 3. Clear? Now let us draw a graph between the different value of angle of incidence and the corresponding angle of deviation. You see the figure. I am drawing a graph. This is for angle of incidence I, and this is for angle of deviation D. Clear? If you draw a graph, the different value of angle of incidence and the corresponding angle of deviation, a graph is obtained like this. The graph shows that first with increasing the angle of incidence, deviation gradually decreases, becomes minimum, then on further increasing the angle of incidence, deviation again increases. That means you can say here, for the angle of incidence I1, suppose there is a certain deviation D, and for angle of incidence I2, suppose there is also deviation D. That means for two angles I1 and I2, same deviation is obtained. And when the angle of incidence is I, suppose I1 is equal to I2, in this case the deviation is minimum, that is called angle of minimum deviation. That means when I1 and I2, that means you see here angle of incidence, angle of emergent, if both are equal, in this case the deviation is minimum. And in such case, this FG ray which is through the prism is always parallel to the base. So in this case, or in the minimum deviation condition, I1 is equal to I2, that I will take as I, and in such case the R1 must be also equal to R2. R1 is equal to R2, that I will take as R. Okay. So in minimum deviation condition, I1 I2 is equal to I, R1 equal to R2 is equal to R. So equation 2 and 3 becomes, now equation 2 becomes R1 plus R2 equal to A. So this now becomes 2R is equal to A, or implies R is equal to angle A by 2. Similarly, consider the equation 3. When I1 I2 equal, the deviation is called the minimum deviation. So equation 3 becomes the minimum deviation dm is equal to 2I minus angle A, or I is equal to A plus dm by 2. Now we are getting the value of I and the value of R. So now the refractive index of the prism mu is equal to, according to Snell's law, sin I by sin R, or that implies mu is equal to, put the value of I and R is here, I is here, so sin A plus dm divided by 2, total divided by sin angle A by 2. This is the Prism formula. Complete. Thank you.